Hi everyone, welcome to another video. Today I'm going to be looking at a trig function application question that involves calculus in it. We've done trig application questions before, but this one's got some calculus in it, and so we need to have a look at this and how we go about that. So let's have a look at this question. So there's some boats in a harbour here. And the question's about tide, which is a bit of a classic question when it comes to trigonometry, because tides go up and down cyclically. Tides go up and down like that. They sort of come up and down, and so they're classically been able. We can easily model those using sine functions and cosine functions. Okay, so let's have a look at this question. Between 6 a.m. and 9 p.m. I don't know why my brain didn't. And 6 p.m. on a given day, the height h, which is measured in meters, of the tide in a harbour is given by function ht is equal to 1.5 plus 0.5 sine pi t over 6, where t is between 0 and 12, which makes sense. T is between 0 and 10 and 12. Does it say what t is measured in? It actually doesn't, this question. So we're assuming that t is hours, but it doesn't actually specifically say that. But for the purpose of this question, I'm going to assume that, which is a safe assumption because it's between 6 a.m. and 6 p.m. So let's say that t is in hours, but it actually doesn't say that. Okay. So first off the bat, we want to have a look at state the period of the function. Okay, so remember that the period of the function is given by 2 pi over whatever is in front of your, your independent variable. So in front of x normally, blah, blah, blah. And so what we're looking at here is we're looking at inside of here, this here, that will give you what the period of the function will be. And what's in front of our independent variable, which is t in this case, is pi on 6. Okay, if you think back to what we did previously, if it was sine 2x, then that 2 is in front of the x. The period will be 2 pi over 2, etc., etc. In this case, it's over pi on 6, so it's going to be 2 pi over pi on 6. So that's going to be our period. What happens here? Well, that pi will cancel out with that pi, and that 6 sort of goes to the top line, if you like. If you write it out as dividing two fractions, you'll see what happens there. And so that's actually equal to 12. Now, our period, because it's the independent variable there, is t, and so the period is actually going to be 12 hours. Okay, so a period of 12 hours. So that's part B, 12 hours is the period. All good. Let's have a look at part B. Part B, determine the value of h at low tide and the time when the low tide occurs. Okay, so we want to know when low tide occurs and what is low tide. Okay, so let's have a look at this original function here. Can I delete? I can delete that. That's good. Let's have a look at that original function and think about when is it going to be its smallest. There's sort of two ways you could do this question. You could actually go and sketch this function. You could get your CAS out and you could sketch this function, put it in there and see where the minimum occurs, and that would be a totally fine way to do it. Let's just actually use our brains to think about this. And when will this be a minimum? Well, it's going to be at its smallest when sine pi t on 6 is its smallest, okay? So we're going to get a minimum, so low tide, when sine pi t over 6 is at its smallest. And so what is the smallest that sine can be? Well, that's going to be -1. -1 is the smallest that the sine function can be. Remember what the sine function looks like. And so you're going to get a minimum when that is equal to -1. Okay, so therefore h will be equal to, or h of t, will be equal to 1.5 plus 0.5 times -1. Okay, so that's 1.5 take away 0.5, so that's equal to 1 meter. Okay, so that means that the lowest height that this hide will get to is 1 meter. The question says determine the value of h at low tide. So that is the value of h at low tide, but when does low tide occur? Okay, so here here we said, well, the low tide will be there. That's the smallest thing. So let's use that. And so we want sine pi t on 6 to be equal to -1. So let's have a think about where sine is equal to -1. Sine is our y value. Where is that going to be equal to -1? It will be this angle down here. So that angle down below there, that is when sine will be equal to -1. So therefore, pi t over 6, that angle will be equal to, what is that angle around there? That will be 3 pi on 2. 3 pi on 2. The angle needs to be 3 pi on 2 to get that sine of -1. Okay, so now we just need to solve this for t to find out when the low tide will occur. I can just cross multiply everything here. So whenever you've got a fraction equal to a fraction, you can just cross multiply everything. You can do that times that is equal to that times that. Okay, hopefully you've seen that before. And so that means 2 pi t is equal to 6 times 3, 18 pi. Okay, the pi's will cancel out, and therefore we get 2t is equal to 18, so therefore we get t is equal to 9. Okay, does that answer the question? Let's have a look at that. Look at that, and the time when the low tide occurs. T is equal to 9 is probably not good enough. It's because it goes on. It doesn't really specifically say the time. Well, t is equal to 9, but let's put a time on it. If it starts at 6 a.m., so 9 hours, 6 a.m. plus 9 hours, and so that'll be, well, 6 a.m. plus 9 hours is 15 hours, which will be 3 p.m. Okay, so 3 p.m. will be the time when it hits. Just let me check. I did my maths right there. 6 plus 9 is 1500 hours, which minus 12 makes it 3 p.m. I think I've done that right. Yes, I have. Let's have a look at that. So that was part B. Determine dH dt. Okay, so we want dH dt, which is the derivative of h with respect to time. So dH dt, looking back at this function, I'm just spreading myself a little bit thin here. So what is the derivative of this function up here? Let's have a look at that. Well, the derivative of 1.5, it's a number, so it's just 0. This sign here will go to cos, and so we'll apply the chain rule function here. I wish I could see both things in one go, but it's going to be 0.5. I'm just going to rewrite it because, no, I'm not going to. So 0.5. The sine goes to cos, so sine, the derivative of sine is cos. The inside stays the same. That's what happens with the chain rule. Inside will stay exactly the same. Pi t over 6. And then we need to multiply by the derivative of the inside. What's the derivative of this inside? Well, it's whatever is in, like, the derivative of 3x is 3. The derivative of 12.9x is 12.9. So here, the number that's in front of t is pi on 6. So we just multiply that by pi on 6. And that is that. We just clean it up a little bit. And so that's equal to 0.5 times pi over 6, so half of pi on 6 is pi on 12 cos pi t on 6. Okay, so there's my derivative. Is that all they wanted us to do? Yes, it is. That's part C. Let's do part D. Determine the exact value of the derivative at 7:30 a.m. So let's think about this. 7:30 a.m., what t value does that relate to? Well, it starts at 6 o'clock. Again, it didn't really define it very well. It starts at 6 o'clock, so that's when time's equal to 0. So 7:30 was t is equal to 1.5 hours later. So t is equal to 1.5, and so we need to sub in 1.5. So dH dt when t is equal to 1.5 is equal to, so we're going to sub that in there. We have pi over 12 cos pi times 1.5 over 6. And let's say it wants the exact value, so obviously we can do this by hand. So let's just check this out. We've got a decimal inside of a fraction, which is always a bit gross. So let's just simplify this a little bit. If we times the top line and the bottom line by 2, we would get 3 over 12. 3 over 12 is 1/4, and so this is actually cos 1/4 of pi, or pi on 4. So that's what it's equal to. That's nice and easy. We know that cos pi on 4 up here, the cos pi on 4 is equal to root 2 on 2. So that's pi over 12 times root 2 on 2. I'm just trying to save space a little bit, but no, I won't try to squeeze that in there. It's a bit squishy. So that is pi root 2 over 24. Okay, so I think that's what it wanted. Determine the exact value of dh dt. That's the exact value. It can't be simplified any more than that. But we do need to put our units in here. What were the units of height? Were meters. And what were the units of time? I'm assuming hours. And so that rate, after 1.5 hours at 7:30 a.m., the rate is pi root 2 over 24 meters per hour. That's how much the tide is changing, the rate that it's changing at that time. Part E. What was part E? Let's have a look. Determine the second time during the given time interval. Time interval is saying that, t between 0 and 12. That dh dt equals the value found in part D. So part D, 7:30. Right, so what it wants is it's asking you, well, when will you get this cos pi on 4? When will that value be the same, effectively? Because when will you get the same value for cos pi on 4? So let's have a look. We could look at the graph, but let's just have a little bit of a think about it. Cos pi on 4. I'm going to say here's pi on 4 here. I'll do it in red. Here's pi on 4. I'll draw a new one. I'll come down here because it'll be a bit clearer. Okay. So what we've got, we want to know when does it equal the same. I'll have to change my colours now. So we've got pi on 4, and remember cos pi on 4 is this x distance here. Okay, so that's that distance there. That's cos pi on 4. So where's another place where you'll get the same value for you get the same value as cos pi on 4? Well, you'll also get it down here. I'll do it in a different color. I'll do it in blue. You'll also get the same value down here. Okay, because that value there, which is 7 pi on 4, if you got cos 7 pi on 4, that will also equal root 2 on 2 because it's in quadrant 4. You'll get a positive cos value. You'll still get root 2 on 2. And so 7 pi on 4 is another angle where you'll get that same value. I hope that makes sense. Again, you could just look at the graph and have a look at it. But there's certain shortcuts you can take in sort of the exam and things where you can just quickly say, well, we're going to get the same value as cos pi on 4 at cos 7 pi on 4. So we can just quickly get that. All right, and so therefore, what did the question want again? It wanted the second time. Okay, so we want to know what the time is. And so looking back at our original, what was it again? Determine the second time, dh dt. And so what we want is that our original dh dt, which is here, we want that to be the same value. So determine the second time equals, yep, so we want, let me write this out. Oh, I'm still on highlighter. We want pi on 12 cos pi t on 6 to be equal to pi on 12 cos pi on 4. So that's what we're sort of trying to find. Okay, that was from the original, from part D. And so what we could say is that that's equal to pi on 12 cos 7 pi on 4. Okay, and so then therefore this must be equal to this. Pi t on 6 must be equal to 7 pi on 4. And that will give us the time where we get that. So therefore pi t on 6 must be equal to 7 pi on 4. And again, we'll cross multiply. And so then we get 4 pi t equals 42 pi. Pi's cancel out, and then we get 4t is equal to 42. So that's 42 over 4, which is 21 over 2, which is 11.5 hours. Okay, so t is equal to 11.5 hours. Also, what that means is in terms of time, if it starts at 6 and finishes at 6 p.m., well, that's half an hour before it hits that 6 p.m. So that'll be at 5:30 p.m. Okay, if it wants it as a time. I'm not sure whether it wants it as time or in sort of like hours since it started, but that would be the answer. It would be 5:30 p.m. Again, you could just chuck everything into the graph mode in your CAS calculator if you've got your CAS calculator, if you're allowed to use it for questions. You could just put it in there and have a look at where it's equal to that value. We could have also just done solve. Where is it? We could also have just solved where those two values are equal to each other, and it will give you that same value of t is equal to 11.5. Hope that makes sense. We'll see you in the next video.